Okay, so today we're actually going to turn our paper sideways because we're going to create a flow chart to teach ourselves about solving two-step equations. So if you want to, you can make your title. I'm going to make mine really small at the top. I don't actually know that I can write on this part up here. So actually I might go ahead and make my title the other way. But I'm going to need all the room I can get. Solving two-step equations. Okay, solving two-step equations. So I am going to go ahead and turn my page, and the reason I'm doing that is because we're going to create a flow chart that teaches us the steps of solving a two-step equation. So I'm going to first just draw. It's going to be three kind of graphic organizer type things that I'm going to write in, because we're going to use 3 steps when we're solving these. So I'm going to say this step goes to this step, that goes to this step, and then once you've done all 3 of those, then you would be finished. Okay? So when we start, and we're going to use quite a bit of grade level vocabulary, so if you'll stick with me, when we start this process, the very first thing we want to do is to make sure it's an addition problem. So what that means is we don't want any subtraction signs in our equations. We talked about integer operations last week, so hopefully in your head you're thinking, well, how do I change subtraction to addition? And the way that we do that is we use LCO. Again, this is only if it's not an addition problem. So I'm only going to use LCO if I see a subtraction sign. The second step in this process is going to be to get rid of the constant. That is one of the words on your vocabulary crossword, so hopefully you have filled it out at this point, and if you haven't, then I would say take the time to go and look at that. The constant is the number in the equation, I'm going to use this sign for number, without the variable. The number without the variable. So it's the number that's not attached to the variable. And the way that I get rid of the constant, so how I get rid of the constant, we're going to add the opposite. So we talked about this with 0 pairs. So if I had a positive 5, the way to get rid of a positive 5 would be to add a negative 5, right? The third thing, I'm going to underline constant here a little bit better. That's definitely one of our vocabulary words. The third thing in solving a two-step equation is to get rid of the coefficient. To get rid of the coefficient. So the coefficient is another really important term, and we're going to use grade level vocabulary this whole unit. The coefficient is the number with the variable, and technically it's the number being multiplied by the variable, okay? So let me just write up here, and hopefully this marker will work. So if I have something that looks like 3x plus 17, okay? Think about the constant is the number that does not have the variable right next to it. So this 17 would be the constant. And the coefficient is the number that's with the variable, the number that's being multiplied by the variable. So this would be the coefficient. And co doesn't mean together. You know, co is you're kind of working with something else, co, right? And the way that we get rid of the coefficient is to do the inverse. We talked about all of this yesterday when we did our foldable over one-step equations. So yesterday's lesson had two parts. One of them was adding and subtracting, one of them was multiplying and dividing. Today, you put both of those together. So 7th grade is two-step equations. 6th grade was where you did one-step equations, okay? So what we're gonna do is I'm going to, on my paper, I'm gonna draw a big box as big as the rest of my page. And we're gonna do 3 examples. And your work needs to look exactly like my work. So if I have some specific steps written, I want you to have some specific steps written, okay? So I'm gonna zoom in here as much as I can. I'm gonna move my paper over because what I want you to see is the proficient work that we're gonna do for each. We actually are gonna have something in class that we call a proficiency model, and that's gonna help us to understand what our questions should look like. So we're gonna start out just by writing the first equation. So the first equation is gonna be 2x plus 5 equals 19. Here's what I want you to understand. I'm gonna draw a line because this is not where we're solving. Could you possibly in your head, some of you, figure out what number would go right here to make this equation true? Yeah, you probably absolutely could, okay? However, when you have something in 8th grade that looks like negative 5x plus 17 equals 1/3 x minus 22.5. There is no way that I can even do that in my head, okay? So we're gonna learn the algebraic process of what it takes every single time, because if we can learn the algebraic process on the small ones, then we're already gonna know it when we get to the larger questions, okay? So if you'll stick with me, I promise it's gonna be for your success that we're showing you the right steps. So let's identify the coefficient and the constant, okay? So the coefficient, remember, is the number that is being multiplied by the variable, the number that's with the variable. So hopefully here, you notice that the 2, I'm gonna put for coefficient, because this means 2 times x. 2 is the number that's being multiplied by the variable. 5, I'm gonna put 5 is your constant. This is the number that it's just happening one time, you're adding 5, and that's it. It's not happening multiple different times. Okay, so I'm gonna rewrite our equation, and I'm gonna start with 2x plus 5 equals 19. In 7th grade, we draw a line down the equal sign, and the reason that we do that is just to kind of keep things lined up. Really, we have to make sure we're staying balanced on both sides of our equation. That is why we're doing that, okay? So let's look back at our first step from our flow chart. First step, make sure it's an addition problem. So if I'm looking here, this is an addition problem, so I'm not going to use LCO. I only use LCO if this is a subtraction sign, and it's not. So I'm good, I'm done with step 1. Check, step 1's done. Step number 2, get rid of the constant, okay? The constant is the number without the variable. We already said that our constant is positive 5, and how do we get rid of the constant? We add the opposite, okay? So the opposite of positive 5, and I'm gonna show it in a different color, I'm going to add a negative 5, and whatever I do to one side, I do to the other, right? Has to stay balanced. What happens to positive 5 and negative 5? Well, they make a 0 pair and they cancel out, okay? So everything else comes down to the next step. I still have 2x equals 19 plus negative 5. They're not on the same team, so they would battle, and you might do some little scratch work, but your scratch work goes somewhere else. It doesn't go in the middle of your algebraic process. I know that 19 minus 5 is 14, and I know that the positive team has the larger absolute value. The positive team would win the battle, so that my answer is positive, right? At this point, the third step says to get rid of the coefficient, we're gonna do the inverse. This variable is being multiplied by 2, So the inverse of being multiplied by 2 is to divide by 2. Whatever I do to one side, I do to the other. Okay? 2 divided by 2 is 1. But here's the deal. We don't write 1x. Okay? So I'm not going to write a 1 right here. A 1 is assumed. That means that they already know that there's a 1. Think about if I were to ask somebody to give me a glue stick, right? I don't say, hey, can you hand me a 1 glue stick? I just say, can you hand me a glue stick? And we know that that means 1, okay? And then we finish out over here. 14 divided by 2 is 7. This is our answer for this specific two-step equation. You're gonna see something and it's going to ask you, your proficiency model is going to ask that you check your work to make sure that it's proficient. We said that x is equal to 7. Well, if x is equal to 7, then I should be able to plug it back into this equation somewhere and see that it is proficient, okay? Kind of running out of space, so I'm gonna do it on the side, but normally I would do this underneath somewhere, okay? So 2 times 7, I'm looking at my original equation, plus 5 should equal 19, okay? 2 times 7 is 14, and then 14 plus 5, and does 19 equal 19? Yes, it does. So this means that my answer is the correct answer, okay? All right, let's go to the next one. It's gonna be the same type of problem, but just a little bit different. 2x minus 7 equals negative 31. 2x minus 7 equals, and I'm gonna put this in parentheses, negative 31, okay? All right, so let's talk about the coefficient and the constant. Hopefully you see that the coefficient, the number that's being multiplied by the variable, again, looks like 2 in this case. The constant, this one's super tricky. It is the 7, but think about what operation precedes the 7, right? Technically, this really means something important for us because when we do LCO, leave, change, opposite, this becomes a negative 7, right? So our coefficient, our constant, because this is a subtraction sign, is going to be negative 7. And we'll do LCO in just a second and we'll get to see that. So I'm gonna rewrite it. So we got 2x minus 7 equals negative 31. And we're just gonna walk through the steps again, okay? So our first step was to make sure it's an addition problem. I'm going back to our flow chart every single time. Make sure it's an addition problem. This is not an addition problem, so I'm gonna do LCO. I'm going to leave the first term, change subtraction to addition. I need the opposite of 7, which is negative 7. And I'm gonna actually rewrite my equation so that I know exactly what I'm looking at. 2x plus negative 7 equals negative 31. So now I am actually looking at my equation as if it's this new equation right here, okay? That marker is not gonna stay there, but this is what we're looking at now, okay? Step number 2 says to get rid of the constant by adding the opposite. So this is where we gotta be really careful. To get rid of the constant by adding the opposite. So if I wanna add the opposite of negative 7, what's the opposite of negative 7? It's a positive 7. These guys should cancel out, right? Whatever I do to one side, I do to the other. 7 and negative 7, they cancel. What's left on this side is 2x equals a negative 31 and positive 7, they're not on the same team, right? So negative 31 and positive 7, this is where some of you might want to come over here and you might want to do some scratch work and battle, right? 31 minus 7, okay, you take that away. Obviously that's going to be a 2, that's going to be an 11, 7, 8, 9, 10, 11. So there's 24. And you have to be so careful. Which team wins the battle? Which team has the larger absolute value? It's the negative team. Awesome. All right, let's do our last step. Our last step says to get rid of the coefficient. I'm up here on this side over here. Get rid of the coefficient by doing the inverse. Okay? The inverse of times 2 is to divide by 2. Whatever I do to one side, I do to the other. Okay? So at this point, this cancels. We already had that discussion earlier. 2 divided by 2 is 1, but we're just going to write x. We're not going to write 1x. 24 divided by 2 is 12, and a negative divided by a positive is a negative. So this is the work that we would do to solve this equation. And then if we're talking about proficient work, we want to have our check step. So our check step says I go back to the original equation, and I'm going to go back to where I've already done LCO. 2x. Actually, I need to, sorry, I'm plugging in my stuff here. 2x plus negative 7 equals negative 31. So 2 times, and if I get negative 12, I'm going to plug in negative 12 because that's what I got from my answer, plus negative 7 equals negative 31. This side should all equal to negative 31, so let's see if it does. 2 times negative 12 is negative 24, and then everything else comes down. Negative 24 plus negative 7 equals negative 31. So are we correct? Yes, we are. The great thing about algebra is you can literally check every single answer when we're doing these equations to see if you're correct or not, and you'll be able to tell. So that's what I love about them. Let's do our last example, and then we'll be done. All right. Last one is going to look a little bit different, and I just want you to have this example in your journal. Again, you don't have to understand all of this by the end of today. This is just lesson number 1, so don't worry. Negative 25 equals x over 4 minus 5. Okay? Some of you guys are probably going, oh my gosh, it looks so different. It does, just a little bit. Let's talk about the coefficient and the constant. This one, the constant's a little bit easier to find. The x is on the other side. It's not a big deal. You're going to see that all the time. And again, in 8th grade, you're going to then go back to where, if you remember, this one had stuff on both sides of the equation. So our constant would be negative 5. And our coefficient is going to be a little bit different because this one has a 4 underneath it, but we said there's something in front of this x. Remember, we don't put 1x, but isn't there a 1 there? So this coefficient is actually 1/4, right? This variable is being divided by 4, where this variable was being multiplied by 2. Okay, so that's just the difference there. All right, let's write it out. Negative 25 equals x over 4 minus 5. I'm going to draw my line. Again, the line is not like mathematically correct necessarily. It doesn't make it mathematically correct. It just helps us to keep things balanced. Our first step says to make sure that it's an addition problem, and it is not. We have a subtraction sign. So we're going to do leave the first term, change subtraction to addition. I need the opposite of 5, which is negative 5. Okay, I'm going to rewrite it just like we did last time. Negative 25 equals x over 4 plus negative 5. Step number 2 says to get rid of the constant by adding the opposite. So here's our constant. Remember, this is gone now that we've done LCO. Our constant is negative 5. To get rid of a negative 5, we add a positive 5. Whatever you do to one side, you do to the other. 5 and negative 5, they cancel. They make a 0 pair, which is exactly what we want. What's left over here is x over 4. And 5 plus negative 25, they're not on the same team, so they battle. 25 minus 5 is 20. And the team that wins, the team that has the larger absolute value, is negative. Now it's just a one-step equation. This is where this one's a little bit different. It says to get rid of the coefficient, you do the inverse, right? If this variable is being divided by 4, then the inverse is to multiply by 4. Whatever you do to one side, you do to the other, okay? There's a mathematical reason why these cancel out, and we're gonna talk about that quite a bit, but 4 divided by 4 would still, again, just be 1. And so that's why those guys cancel out. So this side we have x. 20 times 4 is 80, right? 2 times 4 is 8, so 20 times 4 is 80. And a negative times a positive is a negative. Only thing we need to do here is check our answer, and then we're gonna just do a lot of practice. We're gonna be in this unit for about 2.5 weeks, and we're gonna be solving equations all year. So don't worry, if you don't understand it right now, it's totally okay. I'm gonna take my answer and I'm gonna plug it back in. So this said negative 25 equals x over 4 plus negative 5. I'm just gonna substitute this negative 80 for this x right here, okay? And we're gonna just try it out. Negative 80 divided by 4. Well, 80 divided by 4 is 20, and a negative divided by a positive is a negative. So this would be negative 20 plus negative 5. And does that equal negative 25? Negative 20 plus negative 5, they're on the same team. So that does equal negative 25. Again, there is so much work to be done with this unit. This is only your map for the rest of our unit. So when you're looking at your work, and we're gonna talk a lot about what proficient work looks like, and proficient just means the work that we are expecting to see, your work should look like this. If you'll notice, on each side, I have the algebraic process for each step, right? I don't just have the equation and then an answer at the bottom. So if you are showing this proficient work, number one, it will help us to see where we're struggling and what answers we have that are correct or incorrect. But then also, if we're not showing that work, we can't help you as much as if we were, okay? So good luck. I believe there's an activity for you to check out, and we'll continue to work on two-step equations for the next few weeks.